cosmic background radiation. We're looking at this radiation that's been streaming towards us since 500,000 years after the Big Bang.
Initially, the microwave universe looked very dull and seemed to be the same everywhere. But when WMAP turned up contrast, the results were spectacular. The baby universe wasn't smooth and boring at all. It was full of fluctuations.
These tiny fluctuations tell us what the variations in density, how much stuff there is, and how it varies from place to place. These denser regions are going to collapse to form clusters of galaxies and superclusters and galaxies themselves. These low-density regions, these will grow and become the empty regions between galaxies. So this picture really is our connection between the universe when it was a baby, 500,000 years old, to the universe today, 13.7 billion years old.
These tiny imperfections in the fledgling universe would become galaxies and stars.
And this is one of the most amazing propositions in physics. The idea that galaxies like a Milky Way that contain 100 million stars once began life as a tiny little crack in the fabric of the universe.
The material in these cracks was filled with swirling clouds of hydrogen atoms. The voids between the clouds grew bigger and bigger. The gas clouds got denser and hotter. Gravity pulled the gas clouds together on filaments, like beads on threads of a web, cosmic web. Where the giant filaments formed large globs, stars and galaxies would grow.
As the universe evolved, gases were able to condense into clouds, which collapse to form stars. The stars settle into a rotating disk that was later to become a spiral galaxy like the Milky Way.
Over millions of years, the hydrogen atoms clumped together and heated up. The atoms began fusing and releasing energy, and the gas clouds started to burn brightly. Eventually, a star was born. All over the universe, millions of stars ignited for the first time.
The appearance of the first stars would have been a truly spectacular event. Had we been there, we would have really seen fireworks. Individual, enormous flashes of light generated as the stars are born and burn themselves out.
The universe has expanded many trillions of times its original size. It was full of newborn stars made of hydrogen and helium. These young stars were nothing like our own sun. They were very unstable. But it was their instability that would make the universe a more interesting place, because deep inside each new star, something amazing was happening. They were creating new elements. The idea that stars build atoms came from the British astrophysicist Sir Fred Hoyle, one of the greatest astronomers of the 20th century. Hoyle didn't believe that the universe began in a single explosion. In fact, he coined the name Big Bang as a term of derision. Hoyle wanted to know where the elements heavier than hydrogen and helium came from. He figured out that stars acted like nuclear reactors, working a bit like a hydrogen bomb in slow motion. But many billion times more powerful. And their nuclear waste was new elements. But it would take years before scientists were able to confirm his theory by analyzing the light from stars.
We are go for main engine.
In 1990, NASA launched the Hubble Space Telescope to unravel some of the mysteries of our early universe.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Hubble promised scientists unprecedented views of the young universe. It would be able to look back through space and time and examine early stars to discover if they were making new elements. But the dream soon turned into the worst nightmare. After it was launched, they discovered that Hubble's mirror was distorted. It saw everything out of focus. It needed corrective lenses. And the only way to fix it was to send up another space shuttle. One of the repairmen was astronaut Jeff Hoffman.
We're working with a $2 billion telescope, and the last thing we wanted was to break something and leave it worse off than when we got up there.
First, the crew of the rescue mission had to capture the crippled telescope. Then execute a repair mission unprecedented in the history of spaceflight. First, they had to open the access doors on the side of the telescope.
The one thing about working on Hubble that is very different from working on a car is you look over your shoulder and there you are in space. The Earth is going by below you, the stars above you.
The astronauts had to carry out fine, detailed work in the most difficult conditions.
When you're working in a spacesuit, your hands are encumbered by thick, stiff gloves. It's sort of like working in ski mittens, and it was quite a challenge.
All went well until Hoffman attempted to close the huge access doors.
I just had to close up the doors, and when I went to close them, they wouldn't close properly. The doors were somewhat warped, and it took a while for it to sink in. This was very serious. If you can't get the doors closed, you lose the telescope.
Using improvised tools, Jeff and a colleague were finally able to close the doors. It took the team 5 days to repair the stricken telescope. Cosmologists around the world held their collective breath. They waited to see if the most expensive telescope ever built would deliver what its designers originally promised.
I well remember New Year's Eve, 1993, December 31st, when my phone rang, and it was an old friend who worked at the Space Telescope Science Institute in Baltimore. He said, "Jeff, you have any champagne left over from your party?" I said, "Yeah, we still have a half bottle in the refrigerator." He said, "Well, crack it open again and drink a glass because we got the first picture back and Hubble works."
This is what Hubble saw. The images were beyond anyone's wildest dreams. Hubble captured the final moments of a star's life when it explodes and blows off gas and dust. It also captured interstellar nurseries of newborn stars, exploding into life billions of years ago, and dark pillars of cosmic dust, millions and millions of miles long, ready to spawn a new generation of stars and planets. But Hubble's true moment of glory was still to come. Over a 10-day period in 1995, the mission controllers pointed the telescope at a distant empty patch of space. What emerged was the Deep Field image, a tapestry of distant galaxies. Hubble was looking back in time to some of the first galaxies and stars created.
It revealed thousands of galaxies that hadn't been seen before, so the universe became, to our consciousness, far richer after the Hubble Deep Field.
It showed for the first time faint images of galaxies formed just 1 billion years after the Big Bang. Scientists then examined the spectrum of light from these distant stars and showed that these early galaxies had already created elements heavier than hydrogen and helium. Sir Fred Hoyle may have been wrong about the birth of the universe, but he was absolutely right about the stars. The early stars acted like giant thermonuclear reactors, creating new elements.
You can think of the creation of all the elements in this room as, in some sense, like a car assembly line. Because in a car assembly line, each part is sequentially added to the vehicle until it's complete.
Fusion reactions inside these young stars released enormous amounts of energy and heat, which forced atoms to fuse to form new, heavier elements, one after the other.